All right, let's get going on today's meeting. So what we're going to be covering today is actually a very, very important class. This is a very pivotal class, and this is a class where we're going to introduce some new techniques and new strategies that we are going to be using for the rest of the semester. And the specific technique that we are going to introduce today is not significance test. We talked about that last time, but today we're going to unlock SPSS. So our statistical goals have gotten to the point where they are starting to get a little bit too complicated for us to do them with our human minds step by step. So we are going to give our human minds a break from doing the calculations. We're going to hand that over to the machines, and we're going to let them do the heavy lifting of doing the calculations, doing the organizing of the data, crunching the numbers, and then our minds are then able to do the important work of interpreting the results and drawing the conclusions. So that's what's going to be at the heart of today's meeting, is going to be that introduction to SPSS, how to use it, how to access it, some of the basics, so that we can go forward in this semester and not worry about having to do endless calculations, but rather how to choose the correct statistical test, significance test, format it correctly for SPSS, and then interpret those results. So this is, again, all in service of our goal of inferential statistics, which is the ability to intelligently generalize from a sample that you know about to a population that you want to know about. And today we are going to continue with our Do It With Me demos. In fact, this is going to be one of the most heavy Do It With Me demo days, as we basically demo how to use SPSS. All right, so what's on the schedule for today is going to be your introduction to SPSS. We're going to start off with how to access SPSS, and we're going to be using IUAnyware so that you can access it whether you're here at the university or whether you're home. As long as you have an internet connection and a computer, you'll have access to SPSS. Now we're going to go over the basics of SPSS, the data view and the variable view, the output window, the variable names, very important tool in SPSS. I'm going to point out some of the most common errors that occur when people begin to use SPSS, specifically when it comes to measure types. And then I'm going to give you the single organizing principle that will solve 98% of your SPSS formatting, data formatting questions. So there's one rule that organizes SPSS in most cases. So I'll give you that rule when we get there, and that will help you make sure that your data is properly formatted in a way that SPSS understands. And then we're going to do another Do It With Me demo. We're going to revisit the evidence for ESP, and we're going to go through that same four-step process that we did last time, but now we're going to do it with SPSS. So last time we used Excel and some manual inputting of formulas into Excel. This time, we're going to do it with SPSS. And last time was your peek behind the curtain in terms of what is actually going on in that significance test. This time is going to be a more practical, how do we actually do this in the real world using a statistical package like SPSS. So it will be our last peek behind the curtain, because as I mentioned before, the math is just going to get too tedious, too involved, too many steps. So we're going to hand it over to a device that is made to do tedious things multiple times, specifically the computer program SPSS. But before we get that, we have another episode of People Like Us Do Things Like This. So last week, there was another belongingness survey, just to kind of see who are the people that are taking this course? What are you like? What are the things that drive you, energize you, make you feel connected? So one of the questions last week was, what helps you feel energized? And some of you responded with music that makes you feel energized. So the playlist that was playing as you arrived today, those are songs that were suggested as songs that energize yourself or your fellow students. And then others were find energy through movement and nature, like hiking, getting outdoors, getting a good sleep. And what that tells me is that this class is full of people who know themselves and know how to recharge and they know how to reset. And that is incredibly encouraging and incredibly important, because the way to success in most endeavors is not just to push harder all the time. You push harder all the time, you get to burnout. If you know how to recharge and you know how to reset and you know how to recalibrate, then you're going to be here for the long haul. You're going to be doing the things that you need to do over the long term. And that's exactly what really, really strong learners do. So the next dimension that we looked at was, what is it that you are hoping to learn in this course? And the one theme that kind of permeated all the responses was the idea of growth. So some of you wanted to get better at math. Others wanted to know when to use which particular statistical test. Others wanted to know how to learn to analyze their own data, whether they have data right now or you're planning for the future in terms of your advanced lab or senior seminar. Those were the kind of themes of what is the connection here in terms of what we're trying to do here. And it's not just looking for technical skill, it's actually identity building, and the idea that we are now transforming from students who are consuming information to actual researchers who are learning to use the tools so they can contribute to the world around them. And then the next thing that we took a look at in this survey was how everyone here has a particular rhythm to their learning. So whether they draw energy from their music, from nature, from reflection, it illustrated the fact that statistics is not just about the numbers. It also has a rhythm. It has a structure to it. So the same way that music has flow and balance, a hike has flow and balance, so does learning how to do statistics. So we here as a learning group here, we know how to find our pace, we know how to breathe, we know how to let things start to click. And that's incredibly important with statistics, because as I told you at the beginning of the semester, things might click for you in the first 3 weeks, things might click for you on week 12. It will click eventually, and that ability that you've shown to just sort of take it as it comes and know that there's ebbs and flows to this is really reassuring that we will all eventually get there if you haven't quite clicked yet. And then the other kind of theme that came out of the responses was that we think here to understand. So many of the responses really touched on the idea of not just learning stats to check a box, not just learning stats because it's a requirement, although that was in a previous survey, but learning stats now to work towards a goal of being able to think deeply, being able to grow in the understanding of human behavior through the looking at data. So that is something that we all shared. We're not just checking off that box, we're actually becoming more understanding, more deep thinkers, more proactive thinkers with our statistics. So as we keep going in this class, treat every problem that comes up, every problem that we try to solve as one more beat in that kind of rhythm and flow of your statistical journey. So it's just one more step in mastering that language that you're going to be using as a future psychologist or a future researcher. And it was really, really encouraging to see that there's energy here, there's curiosity, there's knowing how to rest, there's knowing how to reset. So just keep that in mind as we continue going through this, and especially today when we introduce a pivotal moment, which is SPSS. So just to kind of recap where we're at right now, we are currently going through the different types of t-tests. So that idea of knowing which test to apply in which situation, that kind of begins with the t-test and with recognizing and learning how to do the 3 types of t-tests. So just as a brief reminder of this from last time, there's 3 types of situations that t-tests apply to. And the first type, which we're going to get to next class, is known as the 2-sample t-test. And this is where you have 2 groups of subjects and you treat one group differently than the other group. So it might be a drug trial where one group gets the drug and the other group gets the placebo. And the important thing is that it's right there on the name. There are two samples in this experiment, and they're both being treated in different ways. So the two sample t-test is one kind. Another situation that often happens in psychology is the before and after test, or the before and after experiment. So you measure somebody before a treatment, and then you measure somebody after a treatment. And if you have one sample that is measured twice, once before and once after, then you're going to be using a paired t-test. And that's a different type of t-test. It has a different type of setup, and it has different assumptions that need to be satisfied. We're going to get to that one after the two sample t-test, but today we're going to return to the one sample t-test. And the one sample t-test, these are all named pretty well. The one sample t-test is when you have one sample and you treat it one way, but then you compare that sample's performance to a known population parameter. So for whatever reason, you know the population amount or the population parameter that you want to compare it to. So for example, if it's an IQ test that you're doing and you want to compare it to the average IQ in the population, we know that average, it's standardized, it's 100. If you're doing a taste test between two options, the default null hypothesis is that 50% of people will choose one option, 50% will choose the other option. So these are situations where you know the population parameter that you want to test against, and you don't have to have two samples or test one sample twice. You can just test the one sample one time and then do a one sample t-test. So that's what we're going to wrap up today with a Do It With Me demo. And for this demo, we are going to revisit the BEM 2011 study that took a look at whether ESP actually exists. So if you recall, this one was called Feeling the Future, Experimental Evidence for Anomalous Retroactive Influences on Cognition and Affect. I really wish it was called, I knew this would happen, Experimental Evidence for ESP on Cognition and Affect. But sometimes you just got to do what the reviewers ask of you in order to get published. So in this experiment, BEM basically was able to collect data that suggested the existence of ESP. So we went over this last time, so just very briefly. The design of the study was that there would be a screen, and on that screen there would be two curtains that were covering two images. And the subject needed to pick which one of those two screens was going to hide an image. And that choice was made before the computer randomly selected which side of the screen the image was going to appear on. So the choice by the subject was made before the computer decided which side the image was going to pop up on. So if they were able to correctly predict which side of the computer screen the image would pop up on, then that would be evidence for ESP, for knowing the outcome before it actually ever happened. And then the other thing that we really didn't take a look at too much last time, but it is going to come up this time, was that there were different types of images. And the two that we're going to take a look at today were the images that were erotic versus the images that were not erotic. So the images that were erotic, the subjects performed better than 50%. They were able to predict which side of the computer screen that erotic image would occur on more than 50% of the time. And as we're going to see for the non-erotic images, the subjects were not able to predict at greater than 50% where that image was going to pop up. So again, in both conditions, we're going to see there were 100 subjects. And for the erotic pictures, they actually predicted correctly 53.1% of the time. So 50% is chance. That's your no ESP exists. And now we have a sample of 100 subjects that actually performed at 53.1%, so greater than 50. Now, the question that statistics is going to help us answer is it greater enough than 50% in order for us to conclude that this is evidence for the existence of ESP? And as we saw last time, this is something that you need statistics for. because the human mind tends to interpret data in support of the biases and the opinions that you already have. So if somebody believes in ESP, they will take that 53% and they'll say, hey, wow, that is evidence for ESP. But somebody who does not believe in ESP will take that same data and they'll say, hell, no, 53.1%, that's not evidence for ESP, that's just chance. And that will go back and forth endlessly until you can find an objective way of actually settling this argument. And as we saw last time, statistics is that objective way. It gives you those tools for that objective evaluation of the performance of these subjects, in this case, at 53.1%. All right, so we got 100 subjects. We got chance level at 50%. We have their performance. They predicted correctly at 53.1%. And the standard deviation of their predictions was 12.53. So what we're going to do right now is we are going to revisit our one sample t-test for a population mean Excel sheet. So if you haven't opened this one up yet, it is available in Canvas, or if you're watching this online, there's a link in the descriptions. So we're going to fill this in, and this time we're going to use SPSS to do what SPSS will do for you. And the reason that I say that is because SPSS will not do everything. So while it is a massively useful tool, we still need to do some of the heavy lifting when we're doing our statistical significance tests. So for example, one of the first things that we need to do is we need to evaluate step one, which is to state the hypotheses, identify the parameters, the significance level, and evidence for that alternative hypothesis. So SPSS will not do this for you. It will not tell you what your null hypothesis is, what your alternative hypothesis is. So we still need to do those in our study. So here for our step one, we're going to start off with the null hypothesis. And the null hypothesis is always about the population mean. So we never hypothesize about the sample mean because we don't need to hypothesize about the sample mean. We know exactly what that sample mean is. I should actually put it up here. It's 53.1. So just to remind us, it's 53.1%. The null hypothesis is the hypothesis about the population if the effect was not there, if the effect was zero. So in our population, the average performance on predicting where the erotic picture would be if there is no ESP in our population, the average performance would be chance, so it would be 50. So in this case, our null hypothesis is that the population mean is going to equal 50%. We then have the alternative hypothesis. And the alternative hypothesis indicates what would happen if the treatment was true. What would our population look like if there actually was, in this case, ESP in the population? Well, if there was ESP in the population, the subjects would be able to, or the population would be able to predict where those erotic pictures are better than chance levels. So the population mean, in this case, would be greater than 50%. So we now have our two hypotheses, our null hypothesis and our alternative hypothesis ready to go. For the alpha level is typically given to you unless you're the head researcher on a particular paper. And the alpha level for this one, I believe, was 0.05. So we're just going to put that there for reference. And the alpha level, again, is how much you are willing to risk finding an effect when no effect is actually there. So how much of a chance are you willing to take that you're going to find something, that you're going to conclude that you found something when there wasn't anything there? So in this particular situation, how much are we willing to risk that we're going to say, hey, I found ESP when ESP in reality doesn't exist? So an alpha of 0.05 says that you're willing to take a 5% chance. You're willing to make that mistake 1 in 20 times. And that's a very typical amount for psychology studies. So that's the one we're going to use today. If that error is much higher stakes, so for example, if you're doing a drug treatment and it's a life-saving drug, and the detriment to society would be horrible if you were to say my drug works, but it actually does not work. Then you choose an alpha level lower than 0.05. You might go to 0.01 or you might go to 0.001. It all depends on how costly it would be to say there is an effect when there actually is no effect. All right, and then finally, evidence for the null hypothesis. The evidence that we have for the null hypothesis is that the sample mean, because that's the evidence that we have, the sample mean equals 53.1%. So that's our evidence that we have so far for the null hypothesis. All right, so that is step one. We then go to step two, and step two is very important when you're using SPSS, because SPSS will not check this for you, and it will crunch numbers that maybe it shouldn't be crunching. So step two is to identify the appropriate inference method and check the conditions. So in this case, we want to start asking ourselves first, what is the appropriate inference method? Which of those statistical tests should I use? And you just take a look at the situation that you're in, and you think to yourself, all right, we got one sample, and we're comparing it to a known population mean. That's a one sample t-test. So we're going to choose to do a one sample t-test. Now, if I pasted this data into SPSS and I told it to do a independent means t-test, SPSS would do it. It wouldn't say, hey, are you sure? Maybe we shouldn't be doing that. So step two is still all on you. Step two is still something that we need to do. Identify the inference method. So we decide on that one sample t-test and then check the conditions. Specifically, was the sample attained randomly? So that is available in the description in the publication. So yes, it was. Is it a large sample? Well, our sample size is 100. Large sample is defined as 30 or more. So yes, our sample is large. And again, the sample size of 100, we get that from the information from the study as well. So step two, we have random yes, large sample yes. So now we're confident that we can go ahead and we can use SPSS to do our statistical test that we have decided on. So step two, done. Now we go to step three. And step three is where we actually do the calculation. So if the conditions are met, yes, they are, perform the calculations, calculate the test statistic, find the p-value, and this is where we now go to SPSS. So for that, we are going to go to a new tab over here, and I'm going to show you how to get here or get to SPSS from the beginning of the internet. So you can just go to Google, and we're just going to search for IUAnyware. So that is IUAnyware, as in software. So this is IUAnyware, and we just hit enter, and it'll be your top one over here. So we click on this link, and it takes you to the University Information Technology Services, IUAnyware. We click on your IUAnyware login, and it will ask you, there we go, to sign into your account. So use your username. Apparently you have to have the @iu.edu, good to know. And then you enter in your password. And then you enter in your Duo security. And then you tell them, no, don't keep me signed in. And then you edit most of this off of your YouTube video. Okay, so once you do this, it'll take you to this welcome to the Citrix workspace. Has everybody made it to this point? Okay, so in this case, you got two options that you can do. One is to actually try to detect the Citrix workspace. And Citrix is a small little program that you need to have installed on your computer. And it's just a program that allows you to communicate more efficiently with the IU cloud server that we are going to be using to access SPSS. That's one way to do it. You can set that up on your home computer. If you're somewhere where you don't have access to actually install stuff on the computer, so for example, in a classroom like this, we're going to go down here to use the web browser. It's still functional. It still does, to my knowledge, everything that SPSS can actually do. So that's going to be the option that we choose. We're going to go to use web browser, and it's going to bring you to your Citrix workspace homepage. Now, yours might look a little bit different than mine, especially if you're accessing this for the first time. It might give you a whole bunch of apps displayed, and you can choose your favorite. Regardless of how it starts up, if you don't have any favorites, your home page will be empty. So what you're going to want to do is you're going to want to search the workspace. You can tell I was searching for that recently. You can just search for SPSS, hit enter. It'll ask you for the if you want the SPSS, IBM SPSS statistics program. You can just click yes on that, and that'll open it up for you. And then again, if you go to apps here, this is where you can toggle while it's opening SPSS. This is where you can toggle your favorites, and there are a lot of very useful programs that are available to you through the IUAnyware app. And as IU students, you have access to these. So I would highly recommend using these as much as you possibly can. A lot of these are really, really nice, and they're for you, and you can use them for free. All right. So this is when this is the tab now that we have our SPSS working in, and yeah, I'll allow for the microphone. And it just needs to load the SPSS program. So we'll just wait a little bit until that occurs. Okay, so this unexpected error has popped up every single time that I have used IUAnyware and SPSS. So for this, we can just hit cancel. It's not going to impact our use of SPSS. And now we are in the heart of SPSS. So I'm going to see if I can zoom in on this. Hey, very nice. Okay, so SPSS is basically set up like Excel. So if you're familiar with Excel, if you've used Excel before, you're about 90% of the way into knowing how to use SPSS. So that's a very good thing to have. So what we have here, I'll just zoom out real quick. This is what is known as the data editor or the data view. And in the data view, this is where we're going to put our actual data. This is where your numbers go. This is where the individual scores actually go. So that's going to be the first thing that we're going to do. So we're going to make sure that row 1, column 1 is highlighted there. And we're going to go back to our t-test, one sample t-test per population mean Excel sheet. And here in the A column here, this is where we have all 100 scores. So one of the big things to know about using SPSS is that you need the raw data. You need the individual scores. So SPSS does not allow you to do calculations if you have the sample mean, if you have the sample standard deviation, but you don't actually have the raw scores. So you need the raw scores in order to use SPSS. These raw scores here are not actually the ones from the study, but I generated them so that they are exactly like the ones in the study. So we're going to highlight that first score. We're going to Control Shift, go all the way down, Control C to copy, allow, and go to IBM SPSS. IBM SPSS uses a lot of the same shortcuts. So when we get here, we can actually go Control V and allow the clipboard to be used. So we are just going to, sorry about that. If anybody has this V right here right now, click on this variable. So var 001 there, click on the header there, highlight the entire column and delete it. And I'll show you why in just a second. All right, so now we have ourselves a blank worksheet. First cell here is highlighted. We can go Control V, and now we have our numbers in our column. Has everybody made it to this point? Okay. And now the last thing that we want to do before we start actually doing the significance test is we're going to go out of the data view here and we're going to go to variable view over here. So variable view is where it lists all your variables. In this case, we only have one, and a lot of the properties of your variables. So data view is where your actual raw scores, your data is. Variable view is where it lists all your variables. This is very useful, especially when the analyses get a little bit more complicated and we have multiple variables and multiple samples. However, I'm going to show you some techniques that are just good habits to develop because your mind will betray you in ways that you have never thought possible when you're using SPSS and when you're trying to do statistics. So you might think to yourself, oh, these are the scores for the erotic images. I'm going to remember that. If I come back, tomorrow, I'll remember that these are the scores for the erotic images. And then you come back tomorrow and you look at it and you say, shoot, what were those scores? Are those the erotic images? Were those not erotic images? Was that another example that Dr. Yurichevich gave? I have no idea what those scores are. Your mind will do that to you. So what we want to do is we want to take this automatic name that SPSS gave our variable, var00002, which is a great name for a variable if you're a robot. We're not robots. We need to give it a great name for human minds, so we can just change it to erotic. And that will be enough to jog your memory so that when you see this data here, and when we're trying to interpret that data, when we get the output, we're not going to get confused. So it's enough. These are the erotic images. You come back tomorrow, you see that heading there, you're going to say, oh yeah, those are the erotic images for sure. That's what it was. And you're going to be able to continue on with your analysis. Now, if we go back to the variable view, let's say that we thought, you know what, maybe erotic isn't enough. Maybe I want to say too erotic, but I want to use leet speak and I don't want to write TOO, so I'm going to put the number 2 and then I'm going to write erotic. Because I want to say that this is too erotic. And you hit enter and SPSS is going to get a little angry at you and it's going to say, hey, variable name contains an illegal first character. So there are certain rules to what you can name your variables in SPSS. One of the rules is that you're not allowed to use a number as the first character of your variable name. So if this happens, you can just click on OK, you go back and, oh, it's actually already changed it back for me. So just be aware that you might try naming some variables some ways and SPSS will just say, no, we're not going to allow that. That's no big deal. You can usually find a name that'll work. In this case, erotic works. Now, once we have this, we are almost set up to do our test. But before we get there, I'm just going to show you one more thing because it is the biggest mistake that occurs when people start to use SPSS. And it's this mistake, whoops, actually we're going to stay right here. It's this mistake right here. It's when you're selecting your data. So when you select your data, sometimes what you'll do, just by mistake, because we're human, is instead of just selecting the numbers, you'll select the header as well. So you'll start off here and you'll say, hey, I want all of these scores. So I'm going to hit Control C, and then I'm going to go over here to IBM, SPSS, and I go Control V, and oh no, I forgot, I put my X there. So you notice your mistake and you think to yourself, oh, okay, well, I don't want that X. So I'm going to take all my scores and I'm going to cut them and I'm just going to paste it over the X and I'm going to get rid of them. And you might notice here that there's this little ruler here next to erotic, and there's these little balloons with a letter next to var 00003. And that is because what SPSS tries to do is it allows you to give it two types of inputs. It allows you to give it numbers, and it allows you to give it words. And what SPSS does is it tries to guess, when you paste something into SPSS, what are you giving it? Are you giving it numbers or are you giving it words? And if there is anything in your data that is a word, like the letter X, it's going to think that you're giving it a column of words. And if you delete that X and you paste over it, it's still not going to change its mind. It's still going to think that you are giving it words. And the reason that this is a problem is because there are certain things that you can do with numbers that you can't do with words. So we're going to keep this variable here, and we're going to call it ero words, or erotic words. And I'll show you exactly what I mean in just a moment. So we have our data that is correct, erotic guesses, and it's got the little ruler next to it, so we know that SPSS is treating this as a number. And what we're going to do now is we're going to do the actual test. So for this, we go to Analyze, and we're going to go to Compare Means, and we're going to go to One Sample T-Test. And one of the wonderful things about SPSS is that all of those make sense. Like, hey, what do you want to do? Well, I'd like to analyze my data. Well, what do you want to compare? Well, I want to compare some means. Well, what kind of design do you have? Well, I got a one sample experiment, so I'm going to use the one sample t-test. So oftentimes, SPSS is very, very nice. Sometimes it's not so nice, and I will point out when it's not so nice. But in this case, SPSS is very nice. So we're going to click on this one sample t-test, and then notice that here in this t-test wizard here, we have this left box. And this left box indicates every single variable that SPSS will allow you to do the test on. And you'll notice that we have erotic, the variable of numbers, but we don't have ero words. So what this is showing you is that if you format your data incorrectly, if you tell SPSS that you're giving it words and then try to correct it, it will not allow you to do a test on these scores over here because it thinks that this is the word 77.4. It thinks that this is the word 44.4. So it won't even be an option. So what you want to do, if you do make that mistake and you paste your data in, and then when you do your test, you can't find your data, right? If you wanted to do a test on ero words, it's not there. If that happens, what you want to do is go back to your data view, highlight the entire column, delete it, and just repaste your data. And make sure that you don't include the word this time, and SPSS will identify it as a number, and then you can go forward and everything will be great. All right, so that is the number one error. So if it happens to you, if you go to Analyze, go to Compare Means, go to One Sample T-Test, and this window here is completely blank, it means that SPSS thinks you have a bunch of words in a column. Delete that column, start over. But in this case, we have our erotic scores. So we're going to click on this, and then using this arrow, we're going to move it over here into the test variables. So we just click on it and move it over into the test variables. If we make a mistake, we can just bring it back, bring it in, bring it out. So it needs to be there. This is where you tell SPSS, these are the variables I want you to test. This is where my one sample scores are. And then the last thing that we need to do is we're going to go down to this test value. And this is by far where the most errors happen in a one sample t-test. And it is when you forget to change your test value. So this test value by default is 0. And what this means is SPSS is telling you, I'm going to take all your scores from your sample, and I'm going to test them against the null hypothesis of 0. I'm going to test them against that population mean of 0. But we're not testing against the population mean of 0. Our null hypothesis is that it's going to be different from 50. So whatever the population mean of your null hypothesis is, in this case it's 50%, that has to go into your test value here. Because we are not testing against 0% correct. We're testing against chance levels, we're testing against 50%. So you have to have that test value updated and correct. And then once that's done, we're going to keep estimate effect sizes over here, and we just hit OK. And SPSS does all the calculations, punches all the numbers, and gives us an output that looks like that. Oh my gosh, sorry. I just noticed what I did. Those were non-erotic scores. And I see some smiles. You guys could have told me before. I'm joking. All right. Those were the non-erotic scores. Let me just back up real quick. No, do not save. All right. So we go to variable view here. We're going to change this. Sorry about that. We're going to change this to non-erotic. And then we're going to go to your t-test here, and we're going to make sure that on this little page down here, we actually have the erotic scores chosen. And we are going to take all those erotic scores, and actually, you know what? This will give you more of a real world kind of way that we do this. We're going to take all those erotic scores, we're going to paste them into SPSS. We're going to go to the variable view. We're going to change bar 0004 to erotic. And we go back to the data view. And now we have two sets of scores, one from the erotic condition, one from the non-erotic condition. One where they're trying to predict the erotic photos, one where they're trying to predict the non-erotic photos. Now we're going to go to analyze. Now we're going to go to compare means. Now we're going to go to one sample t-test. And now we have a more kind of typical setup where you have multiple variables that you can choose. In this case, we're going to choose just the erotic. Test value stays the same until you change it. So we put it to 50 already, so it's still there, it's still good. So now we have the correct test variable. Now we have the correct test value. Now we hit OK. And now we get the output that I was looking for. Does everybody have numbers that look like that? Does anybody not have numbers that look like that? Okay. So now we got numbers that look like that. Let's take a look at what those numbers actually mean. So this is the output, and what we're going to do is SPSS does a lot. It does a lot without you really having to ask for a lot. So one of the things about SPSS is knowing where to look, because you have an abundance of information now, but where can we find the info that we actually need? So to begin with, we're going to start with those two tables at the top of your output. So you'll notice that right at the top it says t-test, just to remind you, hey, that's what you did the t-test. And then above, let's zoom in a little bit on those. Above the top table, it says one sample statistics. And then above the second table, it says one sample test. So it kind of reminds you, it's very helpful. It reminds you, hey, you know what, just in case you wanted to double check, we ran you a one sample test. And this is something that's really good to kind of check and consider, because it's easy enough to just, a slip of the mouse, you choose the wrong test, you run the wrong test. At least SPSS will let you know which test you actually ran. So SPSS in this output here has basically done all of this calculation for you, and we're going to see where you can find that information. The first thing I want to point out is this top table here and how incredibly, incredibly important this top table is, because not only does it give you some good statistical information, this is your double check against human error. So you could see today already, I did some human error. I put in the wrong scores into the wrong label. So human error happens. It just does. And this is your insurance policy against human error. So the first thing that you want to do is you want to check out these one sample statistics, and you want to say to yourself, did I paste the right number of scores? I'm supposed to have 100 scores in there. The paper said 100 scores. I was given 100 scores. Did I put 100 scores into SPSS? And SPSS says, yeah, you gave me 100 scores. I have 100 scores. I have an N of 100, 100 scores. I did that. So that gives you confidence that you did it correctly. And also, if we wanted to fill in that formula there for the T statistic, that N of 100, that's that N right there. It's the size of your sample. But important for our purposes, it lets you know, yeah, you put in the right number of scores. let's say that I didn't catch the error that I made, and I didn't know that I pasted in the wrong information. The next thing that I could do is I could take a look at the mean. And the mean I know is supposed to be 53.1. I oftentimes calculate it in Excel before going to SPSS just so that I know what to look for. So when I see that 53.1 there, I know I pasted the right numbers into SPSS. I know I put the right scores in there. So again, that gives you confidence to go forward with your interpretation of the data. And that mean sample, or that sample mean right there, that is that value right there, if you're going to do the equation. And then the standard deviation, Excel calculates that for you as well. And that is that part of the t-statistic equation. And then Excel even does that standard error of the mean. And that is the standard deviation divided by the square root of the size of your sample. Excel does that for you as well. I mean, SPSS does that for you as well. So that first table up there, double check it. It's got a lot of good info on there, but it is your insurance policy against making silly little human errors like the one that I made just trying to do this live today. All right, so check that first table. Don't skip over it. Now we're actually going to go to where we can find the info for our significance test, and that is in this second table. First thing you want to check in this second table is this test value right here. Make sure that the test value is your null hypothesis test value. Make sure that it is what you want it to be. So we want it to be 50. SPSS is telling us, yeah, I did 50. Double check that, because especially when you do a number of t-tests in a row, SPSS will not update your test value until you tell it to. So if we did another analysis today and we were comparing IQ scores to the population mean of 100, that test value needs to be updated. And if we ran the statistics, we would double check, is my test value 100? And if we saw 50 for the IQ test, we'd be like, oh no, I need to do that again. So SPSS is very friendly and kind of giving you a number of opportunities to make sure that you've done it correctly, to increase your confidence that you've actually done that, entered in the data correctly. Incidentally, that test value of 50, that is your null hypothesis population mean. So that's that part of the equation. And then finally, we get to the actual heavy lifting that SPSS has done for us. So first thing, SPSS has calculated the degrees of freedom. So if you recall last time, degrees of freedom is the size of your sample minus 1 for one sample t-test. And there it has degrees of freedom 99. But perhaps most helpfully, SPSS has actually calculated the t-statistic. So this is that t-statistic. That is that right there. That is what we spent 20 minutes calculating last class. And now SPSS has done it in a fraction of a second. So again, very powerful way to do statistics as long as you kind of understand what is going on. And then finally, SPSS will actually also calculate your significance. It'll calculate your p-value. And not just your p-value, but it'll calculate your one-sided p and your two-sided p for you. So one-sided p is for a directional test, when you're testing whether something is bigger than something, or if you're testing whether something is smaller than something. Two-sided p is for non-directional, if you're just testing whether something is different than something else. For our study here, for the ESP study, we want to know, did the subjects do better than 50%? So that is the one-sided significance. So we take a look at the one-sided p, and it is a p-value of 0.007. So that is your information. So what we're going to do now is we are going to put some of this info into our one sample t-test here. So just real quickly, because I was on the wrong one. I'm going to update that as if nothing happened. So our t-statistic, we have it here, 2.514. So we pop that in here, 2.514. Our degrees of freedom, SPSS has calculated that it is 99, so we can put that here, 99. And then our p-value SPSS is calculated at 0.007. So we can put that here, 0.007. Put that here, 0.007, just so that we have everything in one place. And now what we need to do is we need to make our conclusion in terms of what is our conclusion going to be. So we go back here and we have this t statistic and we have this p-value here. And I just want to help you kind of visualize this. What is it that we're actually testing? What is it that we've actually done here? So to kind of visualize that, we're going to go back to our t-distribution statlet, and we are going to calculate the value, calculate an area under the t-curve. The degrees of freedom is 99. We got that from our SPSS output. So we're going to plot that distribution. We're going to calculate the area to the right of a value because we are calculating greater than, and greater than is to the right of a value. Is our sample greater than 50%? And then the value here is your t statistic. So that is 2.514. So we can go back here and we put in 2.514 and we calculate the area. And you see this little blue area here. We're going to show the labels on the plot. That area is that 0.68. That's that 0.007, but just in percent wise. This is your t statistic right here of 2.514. But importantly, this t distribution here, this is your null hypothesis distribution of sample means. And our sample comes in here. So it is very unlikely to have come from the null hypothesis population. It is very unlikely to belong to this population because the only way that it belongs is if it was really unlucky and we got a really extreme value here. So our conclusion, because our p-value is small, specifically because it's smaller than our alpha value, our conclusion is that our sample does not belong to this null hypothesis population. Our sample does not belong to the no ESP population. Our sample belongs to the ESP population. So we would reject the null hypothesis and we would technically fail to reject, but we're going to accept the research hypothesis, and we have found evidence for ESP. All right, so does that interpretation of the SPSS output make sense to everybody in terms of where to look and what to look for? All right, so before we get to the non-erotic pictures, just a couple of other things that SPSS can do for you. So you might have noticed this little tidbit of information right here. SPSS actually will calculate the 95% confidence interval for you of the difference. Now, very importantly, that of the difference is a key term there, because what SPSS has done here, it has calculated your mean difference between your sample and your population parameter. So remember, our sample performed at 53.1%. Chance levels in a population would be 50%. What is the difference of that? It's 3.1%. So that mean difference is the center of your confidence interval. And then the lower bound of that is that 0.6494. The upper bound is that 5.5506. But this is importantly of the difference. So if somebody asks you what was the performance of the sample, we would have to do some more mathematical adjustments to this calculation. But if they ask you, well, how much better did the sample do compared to chance? You could tell them, oh, they did 3.1% better. And I am 95% confident that the population actually did 0.64 all the way up to 5.55% better. So SPSS will calculate those confidence intervals for you as well. All right, so a few more things just to kind of ground this in real world psychology reporting and real world psychology research. We'll go back to the BEM study here. And just to kind of show you where these numbers would be used and where you're going to encounter them in the results and discussions. So BEM wrote that across all 100 sessions, participants correctly identified the future position of erotic pictures significantly more frequently than 50% hit rate expected by chance. So that future position of erotic pictures significantly more, that is saying we accepted the alternative hypothesis, and then that 53.1% there, that is your sample mean. That is the evidence for it. And then we have, that is your sample mean right there. And then this T statistic that he reports, T 99 degrees of freedom equals 2.51. That is this T statistic right here with these degrees of freedom. So that is, when you're reading it, that's what it means. When you get this, that's how you write it up. The two of them go together. And then this p-value of 0.01, that is a rounded p-value for this one-sided p right here. And then finally, we don't cover this too much in this introductory course, but you have been reading about it. This is the effect size right here. So this is Cohen's D, and the effect size for this 53.1% was 0.25. SPSS will actually calculate that for you as well. So these were the top two tables. If we scroll down just a little bit, we'll see that last third table. And it actually does have Cohen's D. And that 0.25 for the effect size of Cohen's D, that's the point estimate right there. So SPSS will calculate that for you as well. All right, so any questions on the erotic analysis of the erotic performance? All right, so how about the non-erotic performance now? So we have the significantly more frequently than 50% for the erotic. Oh, sorry, we should finish up our steps. So we just did step 3. I kind of jumped the gun here. We do step 4. We make a conclusion about the hypothesis in the context of the problem, and that is where we rejected the null hypothesis, the idea that there's no ESP for erotic pictures, and we accept the research hypothesis, the idea that we have evidence for ESP for at least erotic pictures. And that, again, is because our p-value here is less than our alpha value. So when p is less than alpha, we reject the null hypothesis and we accept the research hypothesis. All right. So now, what about the non-erotic pictures? Well, this is what BEM had to write about the non-erotic pictures. In contrast, there, the subject's hit rate on the non-erotic pictures did not differ significantly from chance. They scored 49.8%. T with a degree of freedom of 99 equals minus 0.15. P equals 0.56. So we're going to go through this calculation now, just again to show you how this works, and just to also indicate why it's very, very important to understand what you're doing and what is going on, and to think critically through this whole process, because SPSS will crunch numbers for you all day long and not ask you why. And as we're going to see here, sometimes it takes a little bit of extra interpretation. All right, so step number 1 for the non-erotic pictures. We got to state the null hypotheses, the parameters, the significance levels, and the evidence we have for the null hypothesis. So now we're going to click on the non-erotic one down here, not erotic, non-erotic. And we basically have the exact same setup here, except the performance was 49.8, I believe it was. Yep, 49.8. All right, so the performance now is 49.8. So our null hypothesis is still that there is no ESP, right? So the mean correct will be 50%. Our research hypothesis is still that there is ESP, that the population mean success rate is going to be greater than 50%. Our alpha level has not changed. What has changed is our evidence for the alternative hypothesis, because now we don't have 53.1%, we got 49.8%. So it's lower. Is it too much lower to indicate that there is no ESP? So we go through step 2, just make it official. Step 2, you want to identify the appropriate inference method. We know we're doing a one sample t-test. You want to check the conditions. So we know that it's random. We know that it's a large sample. It's over 30, so that is all good. So then finally, step 3 here, we're going to do the calculations, calculate the test statistic, and find the p-value. So for that, we go back to SPSS. We can close out of, you can either close out of the output window here by just clicking on the X, or you can go back to your data set. You can toggle between the two with these little button down selections down here. I would highly, highly recommend that once you are done interpreting, especially in the beginning, once you're done interpreting your significance test, close this out, because if you don't, SPSS will append to this and you'll have another significance test below it. And then it'll continue to append to it and just stick significant tests below that. And what that does, especially when you're new to SPSS, is it increases your chance that you're going to look at the wrong table when you're doing your interpretations. So if you're doing your homework and you've just completed question number 1, and now you're on to question number 2, don't just go here and start doing question number 2. I would highly recommend go to your output here, exit out, close it down. You can save it if you're on a computer and you think you might want to get back to it, but we're going to say no. And then now it's going to give you a fresh page. You're not going to have to worry about misinterpreting or interpreting the wrong table. Okay, so we have our erotic, we have our non-erotic pictures. You know what, just to make this a little bit easier, I'm just going to delete that erotic tab right there, because clearly this has been a trying demo, but we're going to make it through. So we got non-erotic. So we go back to analyze. We go back to compare means. We go back to the one sample t-test. Now we have the non-erotic over here. We want to move it over to the test variables. So we just click on it and we choose test variables over here. And then once again, double check that your test value is what you want it to be. Especially when you're doing your homework, your test value is going to change question to question to question. SPSS will not change it until you do it and you tell it to change. So this is still going to be your null hypothesis mean. In our case, it's 50. So that is completely correct. And then the last thing we're going to show before we hit OK here is you notice that SPSS calculated a 95% confidence interval. Up here in options, this is where you can indicate the size of your confidence interval. So the default is 95, but if you want a 90% confidence interval, you can change it there. If you want 99, you can change it there. We'll keep it at, let's go to 99 and we'll hit continue, but that's where you can change those confidence levels there in options. All right, so everything looks good. We got our test value. We hit OK. We've seen this before, but now it's in the right context here. So does everybody have those numbers? It's all good? All right. So those are the numbers that we wanted to see. So let's once again focus in on those top 2 tables there. Once again, that top table, when we're doing our T statistic, that top table, the one sample statistics, is going to be your best friend, because you are going to make an error and you are going to catch it there. So again, check to make sure that you gave SPSS the right number of scores. We're supposed to have 100. Yes, we actually do have 100. Check to make sure that that's that value right there. Check to make sure that the mean that you calculated in Excel matches the mean that you calculated, that SPSS calculated for you. Yes, it does. It's supposed to be 49.8. It actually is 49.8. There's the corresponding value in the equation. Standard deviation, if we need it, SPSS calculated it there. Standard error of the mean, if we need it, SPSS calculated it there, and that is that portion of the statistic equation. But of course, very importantly, this table right down here, check your test value. make sure that it's actually the test value that it's supposed to be. So test value is 50. Yes, it is. That's what it's supposed to be. And now we can calculate or look up our T statistic. First, our degrees of freedom. We look up our degrees of freedom. It's 99. We look up our T statistic. It's minus 1.45. So this is the minus 1.5 that they found. It's just rounded up. So we got that T statistic, minus 1.45. So let's enter that in so that we have that in our information here. So we got minus 0.145. Yeah, we got it. Degrees of freedom equals 99. And then the last thing we're going to do here is we are going to take a look at our significance. And remember that this is a one-sided significance test. So we have our one-sided p-value here of 0.443. So 44% is our p-value there, so 0.443. So we go back to our Excel sheet and we put in 0.443. And at this point, we're going to pause for a second, because if you recall what we saw in the experiment, we saw a T statistic of minus 0.15. That is exactly what we got. But notice the p-value here is 0.56. We found 0.44. This is 0.56. That is way different. 0.145 versus, minus 0.145 versus minus 1.5. Minus 0.15. That's just rounding. That's just rounding to a significant digits. But we're off here, right? The p-value that BEM reported is 0.56. The p-value that we got is 0.443. So what happened? Well, what happened was SPSS does what SPSS does, and in this case, it's not what we wanted it to do, and I'll show you exactly what happened. So we have our T statistic of minus 0.145 and degrees of freedom of 99. So let's go to our applet here, and we are going to calculate to the right of a value, and we are going to put in minus 0.145 for your T statistic value here. And we're going to go calculate area, and we're going to see that the area here is, that's horrible highlighting, the area here is 55.75%. That is exactly what BEM found. So the area that we wanted is correctly calculated by this T statistic. So what happened? Well, what happened is that when SPSS calculates this one-sided P, it doesn't know if you're looking for larger than or if you're looking for smaller than. It doesn't know if we were predicting higher than 50 or if we're predicting lower than 50. So it will assume that whatever is the smaller of those two values is the direction that we wanted, and it will report that value. So this 44%, this 0.443, we go to our applet, that's not the value that's to the right of this T statistic. That's the value that's to the left of the T statistic. And that's what SPSS thought we wanted, because this is the value that's less than 50%. SPSS will report your less than 50% value. This is where we needed to double check SPSS and say to ourselves, whoa, wait a second. This is a negative T statistic. So if I'm doing to the right of a value because I want to know greater than 50%, ESP should give me higher than 50% performance. Well, I'm going to have to slow down a little bit. I'm going to have to calculate to the right of a value, and that is 55%. So not what SPSS gave us, but the opposite side of the distribution is the actual correct value. So that's why when BEM reported it here, this p-value is 0.56. It doesn't match the SPSS value because SPSS gave us the smaller statistic. We wanted the other side of the distribution. So just one more time, because it's very important. we wanted this side of the distribution because we were looking for a sample score greater than 50%. It gave us this side of the distribution because it gave us the area less than 50%. So just keep an eye on SPSS. It does things right 99% of the time, but every once in a while you get something like this, it creeps up on you. So always take a look at the numbers and ask yourself, does it make sense? And take advantage of this applet and plot those values so that you can get a really good understanding of what that p-value means and what that what those t-statistics actually are actually representing. All right, so let's wrap this up. So we did the calculations, we calculated, we found that p-value. Next thing we need to do is we need to conclude, make a conclusion about the hypothesis in the context of the problem. So for this, we go back to our Excel sheet for the non-erotic images, and we now have a p-value. And well, let's get that correct p-value in there. All right, so now we have a p-value here, and this p-value is greater than our alpha level. So the p-value is greater than our alpha level, and because it's greater than our alpha level, we fail to reject the null hypothesis. That doesn't even fit. So we're just going to say that we reject the alternative hypothesis, and we're going to be nice to our human minds. We're going to say accept, knowing full well that if we talk to a statistician, we're going to have to pause and say fail to reject. But we're just going to put it here. We accept the null hypothesis, no evidence for ESP in non-erotic images. We reject the alternative hypothesis, and that is our conclusion. All right, so once again, our scientists now can agree. So 53.1% evidence for ESP, but only for erotic images. I like how they're still yelling about this, even though they are now going to be in agreement. And once again, this is just what we are going to be doing for the rest of this semester, using SPSS to do the calculations, but importantly, knowing how to double check, did we put the information in correctly? And also knowing how to find the information in the output, and then always having that critical thinking mindset where we're saying, does this make sense? Use that applet, visualize what that t-statistic actually means. And the more you do that, the more it'll start making sense, the more it'll likely click, and the more skill you'll be able to develop using this really, really useful tool of SPSS. All right, any questions on anything that we've done today? All right, so that is it for today. So next time we are going to start up on our next t-test, which is the 2-sample t-test. So we are going to, from here on in, have a brief introduction to kind of like the logic of what we're doing, and then the rest of the class is going to be SPSS. So I will come up with the data sets, we'll come up and take a look at some really interesting, classic, controversial psychology studies and see how the actual tests were done that made these actual contributions to the world of psychology. But other than that, we are done for today.